Hey everybody, welcome back to Tech Talks with CodingNomads. I'm here today with a former CodingNomads alumni, Heather Whyte, who's now a software engineer for a fintech company in London. And it's a real honor and pleasure to have you here today, Heather. Thank you for joining us.
Thank you so much for having me. I'm really, really excited.
Yeah, it's so great to see you and to chat with you. Heather and I worked together, what was it, 2018, 2 years ago?
2018, back in
Yeah,
the day.
and Heather's goal was to become a software engineer, work in fintech, and move to London. And she did 1, 2, 3. She nailed it all out of the park, and she's been there ever since, working as a software engineer. And so it's a real pleasure to learn from Heather today. And on that note, Heather, what are we going to learn?
Yeah, so I'm very excited to talk today about microservices. And don't worry, introduction to microservices and what they are, because this is something that right now at my job, I work it day in and day out. And when I was applying to this job, and most jobs in fintech, I would see this word pop up all the time, and I was like panic because I didn't know what they were, and I hadn't built them before, and I just was so overwhelmed by the thought of having to understand this. But now that I work in them, I'm like, oh, yeah, microservices, whatever.
Right.
So I'm excited to share a little bit of knowledge, and I hope some people can learn something from it.
Nice. One thing that I've learned a lot through my software engineering journey is that oftentimes before you learn a concept like this, it feels really intimidating, and that's going to take you weeks and months to learn. And then you just put in a couple hours, maybe a couple of days, and all of a sudden you demystify it and you realize like this is actually totally doable. One of my favorite personal anecdotes about that, and I think we actually chatted about this once upon a time, but Hibernate and Jpa, which is a big thing in Java, ORMs. When I was many years ago, when that was first coming out, I was really intimidated by it. I looked at it a few times and I was like, where's the sequel? And I got really intimidated by it, and I kind of shied away from it for many months because I thought it was going to be really hard and so on and so forth. And then finally, after many months, I was like, I need to learn this. Everybody's using it. And I spent 2 or 3 hours watching videos and doing tutorials, and boom, I learned it. So it's really interesting, especially as you move further and further along in the software development journey, how when you're looking at something like, in this case, microservices, it seems like this massive concept that you're never going to be able to figure out. But then once you just put a little time into it, it starts to demystify. So I'm personally looking forward to demystifying microservices. And should we just go ahead and jump in? You want to share your screen?
Yeah, that sounds good. So let me share my screen here. Boom. See that all right?
Yep, perfect.
Awesome. Yeah, so this is an introduction, as I said, to microservices. If you don't know, that's totally okay. This isn't something that you would normally learn right out the gate, but basically what microservices are is a software architectural style, or to put even more simply, it's just a way that people design the software applications. So wait, before you're beginning, I know the target audience for this is people who are entering software and not necessarily the people who plan to design entire systems. So even if you're a new developer though, why do you want to know about things like software architecture, which is what all the fancy people with the fancy hats, those are the jobs that they do.
Right, yeah.
However, there is a lot of interesting stuff about software architecture that is really helpful for you to know, even if you're not the one designing it, because it's all about the way that the system's built, the internal design, the organization of the software system. So having a good software architecture helps the system be faster, more performant. It makes it easier to add new features rather than if you're going into this large, terrifying existing code base that's not well built. It's like a house of cards that could fall over at any second. So you might not be designing a whole system on your first job, but you will be adding to them. So it's good to understand how it works, and even better, why it's being done that way.
It might be, an analogy might almost be something like city planning, right? Or infrastructure, I'm thinking for highways and interstates, right? If you if it's unplanned and you don't go into it with any kind of architecture, any kind of understanding of architecture, in this case with software development, you're going to be looking at major traffic jams all over the place because there's just very little thought put into it. So with a little bit of thought, you can think, okay, let's put the road here. We need some roundabouts here, and so on and so forth. So
and exactly. And something that might work well with, a town of 300 people is not going to work the same for like a city of 3 million.
Right.
And so if you built it that way and then just expect it to always work as you expand out and as your little one-off software project grows into this like giant multi-million dollar business, then like that's just not going to work.
Right.
Even if you started up in your garage. So, but yeah, that's a very, very apt analogy for that. Plus, you know, yeah, you may not be an architect now, but that doesn't mean that's not a role that you could have in the future. So it's good to start thinking about these things.
Yeah.
Yes. So you, I'm sure, Ryan, like when you were working on back in the day when you were working as a software engineer, you had to start thinking about software architecture, like even pretty early on in your career, no?
100%. Yeah. I mean, typically you come in as an entry-level developer. You're rarely architecting a brand new system from scratch when you're getting started, but shortly thereafter, as soon as you have a year or two of experience, as I'm sure you've learned, you kind of start becoming the person that needs to make decisions, whether or not your official title is software architect. You start making architecture decisions pretty quickly, you know, within a year or two of starting.
Yeah. So what I want to talk about first are just, before we get into microservices, I'm just going to go over a couple of other quick architecture styles you might have seen before, and you might have even built before if you built little side projects. Nice. Everything, even little tiny houses, has a bit of architecture to it.
Right.
So the most common one is, well, not most common, but a very common one is called the layered architecture. So this is one I first learned actually when I was at CodingNomads, because it has, for instance, the classic MVC, or like model view controller, is an example of a layered architecture. Data enters its way from the top and it works its way down the layers. It works really well on certain types of applications, but it's definitely one that as an application grows larger and larger, it has the potential to get really big, and which is sometimes called a monolith because it's giant and intimidating and one big individual thing. Yeah, it's a pretty common one, right, Ryan?
Totally. Absolutely. Yeah.
Next one is we have event-driven architecture. So this is one where you have an architecture that organizes itself around waiting for components to change states and having that trigger major actions. So if you're waiting for a process to hit, and then that will trigger something else, and that will trigger something else. So that can be described as an event-driven architecture. One that I find really interesting to read about, but I've never actually worked with, it's called a space-based.
It's got a great name.
It's got a great name, right?
Yeah.
It just makes you want to work with it because it sounds like something they'd work on like SpaceX or something. It's actually one that's actually quite good for like e-commerce businesses and stuff, but it's an applications that get huge unpredictable spikes in traffic.
Okay.
So it sort of replaces the concept of central database that can get clogged up with these like big spikes, and instead has a lot of like in-memory objects. And then last but definitely not least, my personal favorite, which is microservices, which is what this talk is all about. So I have plenty of time to dig into that.
Wonderful.
Yeah.
So why would you say microservices in this list of 4 here? What is it? And you know, I'm sure we'll talk about it in the further as in this discussion. But why, at a high level, do you like microservices so much?
Yeah. There's a definite bias of just like, you know, familiarity. But part of the wonderful things about microservices is that you're able to make a system modular, like by design. You can make a modular layered system or event-driven system, but by design, microservices have you think about what are the different components to this architecture, how do they work together, which parts need to be tightly coupled together and which parts are independent. And that gives you a little bit more freedom and flexibility, sort of like to pick and choose what you're using, and also to give it a bit more resiliency at times as well, because then your entire system isn't all tied up together, but instead you have all these different microservices as opposed to one giant service. Right. One of my favorite analogies for microservices when I'm explaining them to people for the first time is explaining it kind of like a soccer team, or as they say over here in London, a football team. Right. But each microservice is like a different player on the team, which has its own specialization. It might be, you know, a defender or a goalie or a forward. And the team works together in order to create and be that application and work towards that common objective of scoring the goals. But if, for instance, you have a player who gets injured or goes down, the entire team doesn't stop working. The entire team can keep going. It might be a little bit, wounded, but it's still much more resilient. As well, you can swap in one player for another if you want to upgrade a microservice. If you have a microservice dedicated to a third-party API and you switch your third party, then you can swap those out a lot more simply because it's not as tightly integrated to the core of your system. This is actually one of the projects that I'm working on right now is about changing a third party. And so because we have the microservice set up, it makes it a lot easier to sort of integrate and then, oh, you know what? This doesn't really meet our needs anymore, so we can make a switch.
Right.
Yeah.
One thing that you're mentioning a few times, which I think is worth pointing out, is you use the word tightly coupled a couple of times. In software development, the idea of things being tightly coupled, and if this is super confusing to you as you're watching this, don't worry, it'll make more sense in time. But in software development, the idea of things being tightly coupled is a big no-no, right? So, and this goes all the way through the way that we write our code to the way that we design our applications and the way that we work with our various databases. Because when things are tightly coupled, is basically you can assume this soccer team playing the game, but they always have to be holding hands, right? They're gonna have a really hard time playing the game if they're always holding hands. And if one of them goes down, it might take all the other ones down. That's an example of a tightly coupled system. And so in software development, we're always trying to find ways to decouple or make our aspects of our application what's called loosely coupled. So I talk about this and teach this kind of stuff in that code level all the time. So I'm really interested to learn more about how we do it at the actual architecture level.
Yeah. Yeah, it's exactly the same principles though, whether it's at that code level or if it's at a higher architectural level. I also love that hand-holding analogy. I'm definitely stealing that.
Nice, take it. It's yours.
Yes. Awesome. So so like Grant said, you want them to be loosely coupled. You want to have your independent services. You don't want them to be all. But so in less analogy terms and more like straight up business terms, questions you might get asked on an interview terms. So it's a collection of services, and each of the different services have their own business purpose. As Brian said, they're loosely coupled. They're independently deployable, which means that you can spin up and start, and you can also shut down. Each of them independently. They're not like, oh, in order for me to exist, I need this other thing, again, with the coupling.
Right.
And also they own their own data. So if you have 10 microservices, most likely you have 10 databases as well, or at least 10 schemas.
That was going to be my next question. So would you, for instance, have, what's the database that you guys are using most regularly for your day-to-day stuff?
We use MariaDB. So it's similar to MySQL.
Right.
So relational databases.
And then do you have a specific instance or cluster of instances for each microservice, or is it a single cluster that has multiple schemas?
We currently have 2 separate clusters, but each cluster has multiple schemas on it.
Got it. Okay.
Yeah. So a little bit of both, depending on again, how separate. We've separated an entire group of our microservices from another group, but there's still some interplay between them.
Mm-hmm.
Yeah. But the big thing too, so as you're talking, we were talking about earlier, if you're dealing with things like Hibernate and Jpa, when you start up your service and you set up your databases, all of that just goes directly to their own schema and setup. So if you change that or you modify that, is just related to that specific database, which is nice.
And so your databases probably definitely end up being smaller, more tidy. It's not like you have 94 tables in a given schema or anything like that.
Yeah, exactly. So there's some that get a little bit bigger depending on what the requirements are, but some of them are really clean and really simple. Mm-hmm. But I can't imagine, because we at LandBay we have about 40 or 50 microservices.
Wow.
So even if that just had one table each, that's a lot. And they'd probably have on average maybe 10.
Okay.
But ranging from 4 to 30.
Gotcha.
per microservice. So it can be a lot, and it keeps it a lot more contained. It's also just easier for you as an engineer to like keep in your head when you're thinking about how that service works and how those tables work.
Right.
Like, and that's actually the thing that a lot of companies do with microservices, because each have their own business purpose. Because my company's not huge, we have a team of about 20 or so engineers, 25 maybe. But we still kind of work on a lot of different microservices each. But when you get to the larger companies, they usually, teams will own different microservices. Mm-hmm. And so that way they know exactly what's happening with their part of it, and they fully control the data, they fully control the deployments, fully control it, making any changes to that. But if you have thousands and thousands of engineers and you're trying to like coordinate between all of you, it would just be, I mean, I know a lot of people do it, but it's terrifying to me.
And it makes a lot of sense. Yeah, like
services.
At a larger company with hundreds or thousands of engineers, if everyone's all using and integrating with a single database, for instance, that's just begging for trouble. Whereas if they're broken up into 10 or 20 different groups and they all have their own kind of database that works with the microservices that they own, obviously that's much more compartmentalized and safer for everyone.
Yeah. It's exactly like that. And the other thing too is sort of going back to the football analogy, or the soccer analogy real quick. So you have all these different services, and even though they are all responsible for their own areas, they also do communicate with each other, because they're all part of the larger application, right? They probably have something to do with each other. So I'm going to show like a super simplified, not fully accurate image of what some of our microservices look like as an example. So my company I work in fintech. We work with mortgage investments. So we have loans, we deal with banks, with emails, with interest, property, borrowers. So each of these is a different concept with a lot of different activities that are happening within it, but they're all very separate in terms of most of the activities that are happening. If you're managing like borrower details, that's very different than calculating interest. Like those don't need to ever overlap for the most part. Mm-hmm. With some exceptions. Sometimes they do, and sometimes they need to talk to each other, and that's generally done through a sort of an API layer, the same way that you would normally have an API that talks to an external party. If you want to, get data from some third-party website, you've probably built an API if you've done any server-side back-end engineering. So this is just the APIs talking to each other from within your same system.
So does each one of these services, so each one of these services basically integrates with the APIs of the other services when and where needed?
Yeah, so they each have, these are little databases, they each have their own separate database. Mm-hmm. But if, say, the borrower service wanted to get some bank details, they would call the bank service API. The bank service would go to their database and then send the data back to the borrower service.
Right.
And so there's different things that you can do and different ways that different companies do it. But you can involve, for instance, we have contract testing. So the same way, some people have unit testing. Right. Contract testing checks that, the API definition I have over on the bank service matches this definition on the borrower service, so that I can call it and communicate. And if something changes on this side, that I'm alerted. Because it flags up that something's changed. So it doesn't stop me from necessarily changing something if I'm doing something on borrower service, but it does stop it from I'm sure you've tried working with an API before, and all of a sudden part of it gets deprecated and you're like, what's happened?
Right.
Yeah.
So two quick questions. One is, and this is redundant, but just to make crystal clear, these APIs are RESTful APIs, right? You're making get requests, etc. Okay. Yes. And then the second one is, are you using a tool to do that contract testing, or is that kind of a in-house implementation?
A little bit of both. So we use a tool called Swagger Diff.
Okay.
We use Swagger files or YAML to have all of our to generate all of our APIs, and then we use contract testing to check that the Swagger files are the same. And then if the Swagger files is the same, then we know that if we make the REST RESTful calls, then they will return the right information, or at least in the right format.
One more quick
also use messages. I didn't diagram this.
No, that's okay.
Yeah, but we do also use messages. So if you're familiar with messages, that's great. If not, that's just another fun thing to look up on the side. Right. But we send messages on RabbitMQ, and what happens is all the services listen to RabbitMQ, but certain one of them say like, oh, I'm listening for this particular event. Like if we created an event that said new borrower event, because we just got a new borrower, then probably the bank service wants to listen for that event so it can save the new bank details. And the loan service wants to trigger some sort of action.
Nice. Yeah, that's cool. So it's not necessarily, so in your microservices, you also have a bit of event-driven architecture.
Yeah, there's a bit of like within the microservice, each microservice is kind of layered. Right. And then they also use some event-driven. So there's multiple kinds of architecture that's all throughout the system.
Right.
So it's not just like, oh, you pick one from a box and like that's how you design the entire thing.
Right.
Yeah. So we kind of touched about a little bit about the benefits of microservices, but I just kind of wanted to highlight again some of the reasons of why you would build it, because this is also a little bit extra work than if you just put everything in one spot.
Right.
Like, to be honest, that's a little bit easier. You don't have to figure out and like think about the domain. If you're adding something new, you know exactly where it goes in there in the one object you have.
Right.
But there are definitely a lot of benefits. It doesn't mean that I'm saying these are good for everything, but it is some things to look at. So one of the things I mentioned is it is actually easier to build and to maintain because you don't need to worry about how it's negatively impacting the other parts of the system as much, because it's much more self-contained, and the only thing you need to your contract with the outside world is just this one sort of like swagger in these events. But how you do it on the inside, that's sort of like up to you within the microservice.
Right.
In terms of like improved productivity, like a lot of that is the fact, again, that teams can focus and the microservice can focus on a specific business purpose. So you can have a little bit more product knowledge about that. You can understand the concept of the system rather than just like looking at individual lines of code. It's a bit more holistic in that sense, I find.
Right.
Improved reusability. Oh, sorry, getting carried away. Improved reusability. So we are able to, rather than, improve. I knew the clap would be good.
Yeah.
Improved reusability, so that you can, when you build something in one microservice, that can be used in multiple places. So for instance, we have a small service that is just really, really tiny. It just deals with calculating working days. So that's used by multiple systems. So rather than them having to have this logic, this like small bit of annoying logic in every single service, they're like, no, we'll just call this like helper service. And
so it's almost like the analogy that I would have in my old fashioned software development brain would be, it's like a util package, right? Where instead of putting this, it's like instead of writing the same method twice, right? Put it in a utility package and have everywhere call that one method. So it kind of sounds like that, but just at a higher level.
Yeah, and like some of them are like that, and then some of them are like these big, like really beefy chunks of like system. So, and that's the nice thing is you have that variety. You can have ones that are really small, and then you can have ones that like literally drive your business.
Right.
And they're still like, they're contained not by actual size, despite the name, but by, this is all doing one purpose. And if that purpose is small, then that's fine.
Right.
That's all it needs to do.
Yeah.
The maintainability of the code as well, again, because it's contained within itself, you don't necessarily need to update everything if you are updating this one part. You can, one of the things that people talk about, and this kind of goes in with technological diversity as well, is you can make microservices in different languages as well. Like, so for us, ours are mostly in Java. mostly because all of our engineers are Java engineers, and so that makes it easier. But we have Python in a little bit, and there are definitely at the larger companies, they use that flexibility a little bit more, where they have some Python microservices, some Kotlin, Scala, whatever is the best tool for that job.
Right.
Because all that matters is it sending out those right communications.
Right.
Yeah.
Yeah. I love the idea. It's super intriguing because there's always, that line, like, you got to have the right tool for the job, and when you do this microservices and you chunk everything out to just being a lot of smaller applications that are dedicated to their one goal, then you have the option to say, like, this would be, if like, this is, we could use Rust for this and it would be 10 times faster, or whatever it might be. You have the option to do that, which also, that's also exciting for your engineering team, because there's always the opportunity for people to be learning new languages and, trying new technologies and all that kind of stuff, which always makes an engineering team happy.
Yeah. And it's also good for us, even if we just want to try something out before rolling it out, even if it's something that, would be good for across the entire platform. We can try it on a microservice first, see if it works, see how difficult or easy it is to switch over. When we've had to do like upgrades in the past, like when we were upgrading Spring Boot, you can do it first on a single microservice, like tweak it out, make sure that it works. One of the other benefits I mentioned here is failure isolation. So like, if you're just breaking one thing, you're gonna be like, okay, I can figure out what's wrong in this one thing, and then I can like port that out to the rest of the stuff across the different microservices. And it does make it a little bit easier to like test, and then like, okay, this didn't work, never mind, we'll just scrap that and ignore it. Or if it does, you can then propagate it out elsewhere. I'm
sold. I'm seriously sold. This is, what I'm enjoying about this and the way that you're explaining it is that it really does just extrapolate on the same ideas that we think about at the code level, right? Is to decouple. For instance, in Java, you create a single class, and that class is only dedicated to its particular responsibility. You know what I mean? And then that goes up to the package level, and so on and so forth. So basically, this is all the good practices that we have in software development at the code level. This is kind of that same exact idea, but at the architecture level. And I get it. It makes perfect sense.
Okay, so now that I've sold you on it completely, I'm now going to tell you what's wrong with it.
Okay.
And not even just what's wrong with it, but like all software practices, like there's not this will work all the time for everything.
Right.
You can't just like say this is the blanket solution. This is, despite what you might see on Twitter about how people just make blanket statements, not everything works all the time, and not everything is a good fit for everything. So just some vague cautions, although again, I'm a fan of the microservices. So one of the reasons I hadn't used them before I started working is because honestly, it can be a bit of overkill for smaller applications. If you're building your little side project for your portfolio for the first time, you probably don't need that to be a microservice, because if it's a Twitter bot that does one thing, like there really only needs one service.
Right.
And not even just like that small, but even just if you're making a simpler application, it may not be necessary, because there is some extra overhead you have to deal with that you get the benefits from later.
Right.
And you can always like turn something that was a small application later on. You can break pieces of that apart and turn it into a microservice, but you don't necessarily need to do that from day one for all applications.
Right.
The other thing that can be bad is if you want to do microservices, but then you start to fall into the traps and the old habits of what you might have had before. And it's called a distributed monolith. So for instance, if you have all these different microservices, but they actually secretly all share one database.
Right.
So it looks separate from before, but then actually it's not. And or if you have things that are completely dependent on another service, and then it looks like microservices, but you actually have all the downfalls of a monolith, of that you can't actually independently deploy things. And if something fails, it actually does cause cascading failures across your whole system.
Right.
So you have to make sure that you're really following the principles behind it. Otherwise, you can just like, it's all show.
And it's like a double negative. You put in all the extra overhead, or not all of it, but you put in most of the extra overhead of creating microservices, but you still have all the downfalls of the monolith. So.
Exactly. So that not so good. And then the last one is when people can get a little bit overzealous. So it's creating something called Nano Services, which is not, it's cool. It sounds really cool.
Yeah.
But it's not. It's when you have like a service that's just like too small.
Right.
Like it's like all this service does is count to 3. And then you have a second service that counts to 4.
Right.
Because you wanted them to be slightly different. You're doing them for a slightly different thing. But then like it gets too small to the point of it's being useless. So if it requires too much hand holding, then it's probably a nano service, and you should probably.
Do you have any tips, or has there been a time in your experience where you've discovered yourself being like, I'm trying to over optimize this and split this into too many services? Or what's like kind of like the, let's say at the code level, I would say like, if it's about a cat, put it in the cat class, right? If it's about a dog, put it in the dog class, right? Yeah. And that's kind of a quick and easy way to understand what should be encapsulated where. At the architecture services level, kind of, do you have a something in your mind that helps you understand whether or not this should stay in this one service that you already have, or whether it should be a new service?
Yeah, I would look to see how much the back and forth conversation it is.
Okay.
Like it should be a request. It shouldn't be a conversation.
Okay.
So if you have service A and service B, and service A is like, well, to do this thing, I need something from B, and B's like, okay, great, but I also need this. Okay. And they're like, they shouldn't be like chatty Cathy's. They should be like, here's your stuff. Business is done. We're moving on.
Right.
And if they're just like constantly sending stuff back and forth, like you're like, just be together already, you know?
Right.
You just want them to fall in love.
Yeah, just be together already.
Chemistry, like it just needs to happen, right? You've seen those couples. You're like, no, you belong together.
Totally.
That's kind of the gist I go for.
Yeah, that makes perfect sense. Nice.
Yeah. Cool. So I mean, obviously I use microservices and like I'm awesome, but there's a ton of other companies. Yeah. There's a ton of other companies that use microservices, and this is just a small sampling that I found via the interwebs. So some really big companies too, and it like Uber, Twitter and Spotify, Netflix, and all of these probably use them to varying degrees and in varying parts. But there is a ton of so this here, I mean, and again, this is a simplified version of what LandBay has. I think we have like I said, 40 or 50 microservices. Here are a couple of diagrams from like the big boys. In terms of each of those, this is, an image I got from Uber, from one of their slides at one point in time. Each of those being different services, all those lines being the connections. So this is one of their network graphs. Also really famous ones to see is Netflix and Amazon. It just is like, you can't even see. Like there's just so much.
Wow.
But to be fair, like their systems are huge. Like it kind of makes sense that you need to break that up a little bit, because no one engineer can keep all that in their head. And never mind all the engineers keeping all of that in their head.
Right.
So this allows them to like break off into specializations. Like I said, have those like business purposes, but still sort of work together. These maps sort of just stress me out a little bit. So
totally.
Yeah. But yeah, so they are used all over the place. Not every company has them, and most companies aren't necessarily going to expect you to know that, like, have used them before, especially if you're like new into the industry. But there are some sort of like skills and things you can learn about that might be helpful to you if you want to learn about, or if you want to work at a company that does have microservices. So some of the stuff we talked about today, and then some of the stuff to sort of read up a little bit more, you might already be familiar with, but REST APIs, very, very big. Databases, I mean, that's true for most server-side jobs, to be honest, but still definitely a good thing to learn and definitely a good thing to understand if you want to work in microservices. Messaging, which is one I also wasn't really familiar with before I started my current job.
Mm-hmm.
But it's having to do with that event-based systems of waiting for an event to trigger something else. And if you ever hear on like job descriptions things about Kafka, RabbitMQ, or SQS, this is what they're talking about with messaging.
So quick question there. And or would this assumption be correct? Because there's two ways for two services to communicate, right? One is through RESTful API calls, and the other would be by one service basically dropping a message into like a message queue or just a stream of messages, and all the other microservices paying attention to that stream of messages and doing something if a particular message pops up that they're interested in. So when I would assume that if it's just one service, let's say I just need to get some user's email address or something like that, I can just make a RESTful API over to the user microservice and get their email address. But if I wanted, let's say, 10 different things to happen in 10 different microservices, I would probably put that event in the message queue and let those microservices find that and then trigger on their own. So I don't have to make 10 API calls. Is it something like that?
That's definitely, the number of calls would be like a factor. I would say also something I think about is a huge thing is if it's synchronous or if it's asynchronous.
Mm-hmm.
Like if the activity I'm doing in my microservice, if I need to know the information right away so I can do my thing, I want it to do it synchronously because I need that now. And
so that would be a REST API call.
Then you want a REST API call. Yeah, exactly. Right. Versus if it's something, there's a phrase that's used a lot. It's called eventually consistent. So when you have event-based messaging, you might not immediately update, but like eventually, like give it a couple like milliseconds, couple seconds. Eventually, all the data will be like up to speed. And if you're okay like waiting those couple seconds because you want to notify them, but you don't really care what happens after that. Like it doesn't bother you. Then you can just send the event out. And they can do what they want. Right.
Or it's kind of like
an asynchronous side of it.
An analogy might be, let's say that I've got some friends, I was just speaking with them about their wedding and their wedding planning yesterday. The analogy might be you're sending out invites or even that online invite where it's like let us know if you're coming versus like calling someone and being like, seriously though, are you coming? So one of them is asynchronous. Like, don't worry, like we'll send these all out and sooner or later we'll get the responses. And the other one is I need to know right now whether or not I need a name tag for you on the table.
Yeah. So if you send out a wedding invite, that's probably be asynchronous. If you're asking someone to marry you, you probably want to know in real time.
Right.
So I like that should probably be a synchronous thing.
Got it. Yeah. Got it.
Yeah. Yeah. So that's messaging. Again, it's usually not something used as commonly on small systems, so on your own like personal project applications, but it is something you can read about and sort of like watch some videos, get a sense for what that means. Right. So the next part again is deployment. So CI is continuous integration, CD is continuous deployment, pipelines, things like Jenkins. So this is packaging the code that you've written and making sure that everything is good to go and deploying it onto the cloud and bringing it to life pretty much. And so understanding how that works, because we talk about microservices a lot. You talk a lot about independent deployment. So it's a good thing to know, and I find that companies that use microservices tend to have more continuous integration, continuous development. So they're more used to pushing changes frequently rather than waiting for like big quarterly releases.
Right. So a quick interjection there, just for anyone who's watching this that isn't sure what continuous integration or continuous deployment, or in my mind, I've always said continuous delivery, but I think they go in hand in hand. But
maybe that. I use acronyms too much now.
But so continuous integration, CI/CD, which is the acronym for it, basically means that, for instance, in pipelines like Jenkins that was mentioned here, instead of for instance, let's say that you push some code up to the main branch in a GitHub repository, and that main branch, or let's say you merge some code into a main branch, basically a system that's set up with CI/CD will, when it notices code has landed in this main branch, your production branch, it will automatically pull that code, run all the test cases against it, build it, and deploy it should everything pass, right?
Mm-hmm.
And that's called continuous integration. Yeah. And the versus you manually packaging everything on your computer and for SCPing, or for instance, FTPing the application up to a server and manually deploying it, right? That would be not CI, not CD, right? So what tools, I would be curious, are you guys using for CI/CD?
So we use, well, in terms of the continuous integration, so we use Bitbucket, so like GitHub, to push our code. So we push our code into master like multiple times a day. Like it goes through a peer review process. Like you write code, you create a pull request, someone looks at it, but it goes in across multiple microservices multiple times a day. And then as soon as it's pushed onto our main branch, then that will automatically, we have a hook between Bitbucket and Jenkins. And so Jenkins is our build tool. And so Jenkins, then we have a pipeline where it builds, and then it runs the unit tests, it runs the service tests, it runs the contract testing, so between the different APIs, it deploys it to our test environment, and then it deploys it to our production environment. So it goes through all these different steps in order to make sure that before it goes into production that, okay, yeah, no, this is good. And then it creates quality controls without actually having to manually do all that quality control.
And now I have a clapping moment.
Okay.
What was I just going to ask? The
pipeline, Jenkins.
Well, I had it, and then my phone started buzzing, and I lost it. So never mind. So you were just saying, you just finished talking about kind of the process, polling, building. Oh, okay. No, I was going to say, like, and on that note, something that you'll hear developers saying oftentimes is called breaking the build, right? So who broke the build, or like somebody broke the build, or what happened? Basically, what that breaking the build means is oftentimes in these CI/CD systems, you'll push up code into this main branch that's hooked up to your pipeline, to your Jenkins, that's going to automatically try to deploy, but it's going to run some tests. And if those tests fail, then that's called breaking the build, right? And it's also why it's really important as a software developer to write good tests, right? Because writing good tests ensures that later when other people come and maybe are maintaining or modifying your code, that they won't accidentally break the build without knowing it, right? So we write these really nice tests so that if something's changed, it'll get detected and the application will not be deployed to production because it'll break the build first. And when a build fails, then Jenkins will stop the process and basically alert the team that the build failed, and here's the problem.
Yeah. Testing is so important, and like it's something. So we do all of our own tests, both the unit tests as well as like we write our service and integration tests. And it's extremely helpful both for making sure you fully understand the impact of what you're doing, but it also it will mock all the other systems out for you. So you can test if I receive this event, if I have this information in my database, what's that going to look like? And then you can see and you can test it out. And it makes it, especially I think in a microservice environment, have that integration testing is really important, because then you can pretend what's coming in from other sides. But just to give you that peace of mind, if you're factoring something, you can test it first. Other people are having their code tested, so when it goes into the branch, you have a bit more confidence before it goes in, and that's what allows you, rather than having a big terrifying quarterly release, you can just always be pushing, always be building, and always be adding more features to your application.
Yeah, it's nice.
No.
So how about on the containers front? So I'm actually, I'm hesitant to say this because it seems like everybody knows what Kubernetes is, or is that even how you say it? I know very, very little about Kubernetes. So if you don't mind bird walking with me for a second, could you explain to me kind of how that's used?
I would love to, but I actually don't use Kubernetes.
Oh, okay. Yeah. Okay. But
So
is it an alternative to Docker or?
yeah. So what containers generally, and this is something again I learned on the job. So containers is literally having sort of, it's like having like the miniature version of the computer and everything you would need.
Right. And we actually did a tech talk with another friend of CodingNomads, and the whole tech talk was about using Docker. So if anybody's watching this and they're curious about Dockers, check out our other tech talk on Introduction to Docker.
Highly recommend.
Yeah.
But that way you can set your Docker up so it has everything you need in terms of the different systems, the different like software, hardwares, the right Python version, everything like that. And so we use Amazon ECS, so Elastic Container System, I believe.
Okay.
So it's very similar to Kubernetes, but it fits within the AWS infrastructure sphere, which is like 90% of our infrastructure.
Right.
So it's not as flashy and cool as Kubernetes. Okay. I know, but it works much better for our needs.
Right.
But what it does is it allows you to do a lot of those things like related to deployment because you have these separate containers. So for instance, if you need to redeploy and restart one of your microservices, you don't have to go through the entire build cycle. You can go onto the ECS and you can just update the task definition that it has stored on the system, and then it will have it saved from the last time that it was created, and then just recreate it right then and there. To be honest, this is something that is very sort of like, it's not a new thing, but it's one of those things that, like, I have a lot of Docker systems set up on my system, and I've set up a bunch of Docker instances, but it's not something I use every single day.
Right.
It's something you're like, oh, let me set this up, and then good. But it's great too, because you can actually, if you are running your microservices on containers, whatever type they may be, Docker, Kubernetes, whatnot, you can actually log into those instances and then see the logs the same way if you were like running it locally on your computer.
Right.
And so that's one of the coolest things I find. So in terms of if you're trying to like debug something, understand what's happening inside that actual instance, you can use Docker in order to go into that container and actually see what's going on there.
Nice.
Yeah, it's a big old interesting but like intimidating world. So I also recommend that tech talk.
Nice. Yeah. I mean, and I think this is especially for those of you who are watching this, it's really easy to think that you need to know everything all the time. And nothing could be further from the truth. What you need to learn is for instance, I in Java with multi-threading, I talk about this all the time. You don't need to, if and when you need to learn about doing really, really intense concurrency and really, really intense multi-threading and having synchronized tasks that are communicating with each other, you can go down the rabbit hole in a hurry in the multi-threading concurrency world in Java. But as an entry-level developer, that's entirely not necessary, because when it's time for you to get really, really good at that stuff, it'll be obvious. You'll be at the job, and you need to dive into this deep concurrency thing. So in this particular case, like I don't have any, I think I did say I was feels a little weird to say I don't know what Kubernetes is or too much about it, because I've never worked with it, but I've been in the industry so long that to me, that doesn't make me think, oh, there's something wrong. I'm supposed to know this. Everybody knows this, because that's a feeling that we all have to fight all the time. And what you need to be focusing all the time is what's right in front of you. Like, what do you need to do next to get the job done? And then over enough time, you'll just be exposed to all of these different things through your various jobs and your friends and your network and your community. And it'll start making more and more sense. So if you're watching this and you're looking at all this stuff saying, I have no idea what any of this is, and I'm never going to have any, how am I ever going to learn all of this? It's just a piece by piece thing, and it happens naturally. There is no 97 technologies that you need to learn before you can consider yourself a knowledgeable person in the realm of software engineering.
Yeah, I'm personally a big fan of like the just-in-time, learning, because there is literally millions upon millions of things you could learn. But I'd much rather, so I know a lot about some of these things because at my job, I use them and I need them, and I have to understand what needs to be built, why that needs to be built, how I can make that better. And it's both more motivating because you have something right in front of you that you're actually building. You can see why you're learning this. But also then you have a practical application that's immediately there. Right. It's good to like have an idea and like know that these other things exist and keep your radar open so that you're open to trying it if you hear about it or you see it and you get an opportunity. And that's probably where I'm at with Kubernetes, is like, oh, I know it exists. I kind of know in which places you might try it, but I haven't yet had any need to switch over from ECS to Kubernetes, for instance.
Right.
So I've kept it sort of at that high level, and that's honestly enough for me for now. If my company decides to switch, or if I work somewhere else that does use Kubernetes, that's when I'll go and do the deep dive into it. But,
right. And like things like RabbitMQ, did you have any idea what RabbitMQ was before you started this job?
No.
And how long would you say it took you to get comfortable with it once you started working with it?
Not that long, because I got to do a couple of like support tickets and immediately got to work on it. Actually, deployments was something that terrified me, and literally one of the first tickets and tasks that I worked on at my job and as a software engineer ever was on implementing that contract testing I was telling you about. So I was using Swagger, which I'd never used before. I was doing it in Groovy, which is very similar to Java, but is not Java.
Right.
And you can't unit test pipelines. So you have to literally find a pipeline and break it in order to see if it's working or not.
Okay.
So like I'd been an engineer for like a couple of days, and my task to like literally, it's fine. Just deploy it on this pipeline. If it breaks, fix it and deploy it again. I was like,
okay. Yeah.
But it's good because then it was like after once you've broken the pipeline like 4 times in the past like hour, then you're like, you're over it. You're like, that's not such a big deal. I mean, normally you don't want to do that. But there's certain instances like where you're actually building the pipeline and you're like, oh, okay. And the only way you get better at it is you learn. Hopefully you have, like I have a really supportive environment to like learn people who would make sure that I had like, if I asked questions, it'd be very helpful, give me some space also to try and figure stuff out on my own. So I've had a fantastic environment in order to like learn and work. And that's what's allowed me to grow so much in the past 2 years. So hopefully you can find that in your future careers.
Nice.
But
that's ideal.
Makes a huge difference.
I think just, I'm going to borrow that line from you because I'm in working with people to help them learn to code. One of the main things I'm always having to explain is I can't teach you everything, and nor can anyone, that what we're trying to do here is get you comfortable enough to where when you see new concepts and new technologies, you have the confidence to take them on. And I'm definitely going to use what you just told me, which is Heather, a former student, landed the job that she wanted, and her first task was to use several technologies she'd never used and a language she'd never used. And she just had to figure, because that's a perfect example of what the day-to-day tasks of a software developer are like. Every new project brings new technologies. In the case of microservices, maybe new languages, and being able to kind of think on your feet and learn new things and be excited to learn those new things. And even though you're going to fail a bunch of times, having enough confidence to keep trying more and again and again and again. Because if you just keep trying in a somewhat focused and intelligent manner, you will get there sooner or later. And then once you're there, it's just like, great, I got that, and then now the next one. And
the thing that's hard, I think, as a junior, and probably honestly still a bit of a challenge at time to time, is you have to figure out how long you should be like struggling to figure this out and when you should ask a question. Because sometimes some people I find will just try and grind it out and they'll be like, no, and they'll spend 2 hours on something that they could have just asked and would have found the answer 15 seconds.
Right.
From asking a more sort of senior person or someone who's been in the company longer, or some people who don't try it all themselves and they just
ask immediately.
Yeah. And so you have to find that balance of you do kind of need to like struggle through a little bit to be like, okay, let me think about this. What actually is the problem? How might I fix it? And then when you go ask the question, you're like, oh, I don't know how to do this. Is it like this maybe? Is it like this? You know, show that you've thought about it. And then it also will help you learn faster rather than people giving you the answer.
Right. And
but don't struggle by yourself forever.
Right. And your colleagues are going to appreciate, and I've been in this situation on both sides of it. One of the best mentors I ever had was somebody who basically told me I was no longer allowed to ask him stupid questions, you know? And he meant it, because I had just started a job and I would just ask him a question before really thinking about it critically. And he was this genius of a developer that I learned so much from. And very, very quickly, I learned that it was a waste of my time and definitely aggravated him when I asked questions that were very simple, that were very easily solved had I spent a bit more time thinking about it, or had I even Googled it, right? And so a really good thing to do as a new developer when you're trying to figure out, have I worked hard enough on this? Can I ask one of my peers or colleagues about this? Is when you talk to your colleagues, say, I've tried this and this. I know that this is not working and this is working. And you can kind of really lay out the situation for the things that you've tried, what has worked and what hasn't worked. And then be like, do you have any thoughts? And then they're gonna be like, yeah, have you tried this? Rather than, how do I do it? You know, like how do I do this is not a good question to ask one of your colleagues, but can you see a problem with this specific thing that I'm doing is a very good question.
Yeah. No, that's definitely, definitely a good approach for it. Yeah. Yeah. That's all that I had though.
Great.
There's a lot of interesting bits of microservices, but it's more so, I really wanted to make them seem less intimidating. So you kind of understand generally the structure of how they work. They shouldn't be that complicated. It's just more of understanding some of like the terms, the overall structure, and again, the components that you might want or might need for it, such as understanding the basics, like understanding REST, understanding databases, understanding messaging. And then go forth and build your own microservices. Yeah.
Well, this has been really, really great, Heather. I really appreciate you taking the time and teaching us. This is really, I think I want to start playing around with microservices a bit more and make sure that we integrate it into our more advanced curriculum, because it's obviously a better, generally speaking, it's obviously a better architecture than a massive monolith, single point of failure kind of thing. And just to kind of summarize that all up, in case we haven't said this previously in the video, is that kind of a lot of older style software applications is a single application that has hundreds or thousands of files in it, and it uses one or maybe two databases. And I called it a single point of failure because if that one database goes down or if that one application crashes, it's going to take down your entire system. And that's where the big negative aspect of a monolith, as well as if you're dealing with a company like Capital One or Netflix and you've got 1,000 developers, having 1,000 developers work on a single code base or a single database is clearly going to be error prone. And so this is just fantastic, and it makes perfect sense that you did a fantastic job of explaining it and of laying it all out for us. So I really appreciate it. Do you have any recommendations for like maybe when you were getting started, were there any websites or tutorials or books or videos, or was there anything particularly that helped you other than, and it's okay if nothing comes to mind, but just for anyone who's watching this, like where would you push them off to next other than CodingNomads, of course?
I mean, well, to be honest, so as you mentioned at the beginning, I did the CodingNomads Java Bootcamp, and it was one of those things where not everything in my current job I learned at CodingNomads. Like I didn't really know much about microservices or much about messaging, but like literally almost everything I learned there was then later applicable in my job. Like
nice.
It was, honestly. But knowing about, especially if you want to be a backend developer, understanding APIs, both by like building them, as well as like integrating with other people's, both to learn good and bad practices. Because once you work with a couple APIs you hate, you'll be like, I'll never build this for someone else to deal with.
Right.
I feel it's a good learning point.
Absolutely, completely agree.
Yeah. And then also working with databases, it's something that can be a bit intimidating at first. And it's easy to want to just kind of hold everything in memory, but I mean, that's just not how most things work in real life.
Right.
And so being able to like work with databases and to try out a couple different ones as well. Some of the real interesting work that I've gotten to do is working with non-relational databases and like just seeing sort of, oh, okay, what's the best way to store information for different things, and branching out, because when you're working with a lot of software applications, like a huge bit of it is just you're dealing with data that you save and then you pull and then you like manipulate a bit and then it goes back. And so those are the big things that you kind of learn about, but they didn't seem as like shiny and fun, to be honest, when I was teaching myself. Right. And now that I've actually gotten into it, I was like, oh no, I wish I spent more time, or I'm still spending time learning about these kind of things.
Nice. Well, thank you so much, Heather. It's so great to see you just crushing it out there, and it's so great to learn from you. And I wish you continued success, and thank you so much for your time. And we'll chat soon.
Yeah, thanks so much for having me. It was really good, and I hope people got to learn something today. Thanks.
And will you share us your slides so that we can add a link to them in the source of this video?
Yes,
cool.
I will do that.
All right. Thanks for joining, everybody.
Bye.
Bye-bye.
Hey everyone, thanks for watching. If you enjoyed this video, please let us know by liking and subscribing. If there's another topic that you'd like to learn more about, leave us a comment. We would love to hear from you. And if you want to become a coding pro, visit our website at CodingNomads.co. See you next time.